Hello, Professor. This is Harshita Sakinala, and we are team number 8. We are presenting our topic missing child identification using deep learning and multi-class KNN. Um, so, as we have discussed before, next slide, please. As we have discussed before, nowadays most of the children are missing and we are unable to trace them because based on the traditional process, if any child goes missing, um, they have to find, like, the parent has to find a police station and lodge a complaint, and then based on the complaint details, the authority people will start to search manually, which is a very time consuming process, and this needs to provide a lot of more efforts. Therefore, to resolve this problem, we are proposing a system using the HOG algorithm for missing child identification system for the profile pictures that are uploaded by the officials. So the pictures are processed and the facial features will be forwarded to an algorithm, and the KNN classifier, which is used to recognize the facial features, is used, and we'll get the comparison result using that. If the match is found, a message will be pinged to the nearest authority or the concerned authority. And if there is no match found, and that if the picture that the user that gave is not relatable, it would mention as no match found. Coming to the related works, we have presented few of the most relatable and also most recent related works here in the presentation. Uh, Mr. David Rajkumar, his paper in 2020, he proposed that deep learning model CNN algorithm for recognition of missing persons in crowded places. Uh, this was much effective for our model because it was guiding us with the facial recognition process, but using another algorithm. um, we did get many inputs from this, and in this paper there was also a key point that he mentioned, um, l- which derived to the major cause of doing this process. um Everybody has a smartphone, and um it's easy for people to capture images of people and uploading it on a server than to click a picture, send it to a concerned department and get the process done. And there's also another two papers that were really relatable to our project, and which were most convenient to look up to. That is a paper from 2020 again by Mr. Ayappan. Uh, it was regarding a novel system for identification of criminals in a facial recognition system. Based on this approach, the cameras were installed in locations to capture pictures of the people, and then uh, an algorithm called HAR cascade or HAAR cascade was done on those pictures, and um, the results were shared. This was much more relatable to our topic, and it was also similar, but the only thing was the cameras that were used in the locations were not able to capture exact pictures, and sometimes the information was missed. We That is the reason we haven't included that reach here. The last paper that I would like to talk about in the related part is the age difference paper that was written by Mr. Ling in the 2007 paper. In this paper, he talked mostly about the aging systems and how recognition of people was very challenging because of the aging. That is why we have used the k nearest number algorithm, which is more efficient with the facial recognition patterns after a couple of years of ages also. So when we move down to proposed system, mm, so based on the previous papers, we have already talked that there were many classifiers and methodologies used, but when we took all papers into considerations and um, all systems into considerations, we found HOG as the best detection algorithm. So we have used HOG, and K nearest neighbor is good with the facial recognition system. So we have taken that classifier into account too. Um, uh, there were systems before also with SVM in play, but the accuracy was not up to the point, as referred by people who have done the researches. The KNN classifier, it works with distance methodology. So the threshold value will be the perfect match with the results of the classifiers. So my friend Sai Kiran will continue from here.
Coming to the model design, we have four phases, namely dataset preparation, environmental setup, building prediction model, and the final phase is prediction. So in the phase one, we'll prepare the required dataset with the missing children images. We have the customized dataset, which will be increased based on uploading the number of children images. Here, the authority and the public will have to upload the children images when the search for child images is not matched with the storage server. In the phase two, we have to which is environmental setup. We have to we have to install the various setup files such as Python, PyCharm, IDE, MySQL, SQL and the required libraries like sklearn, face recognition, etc. So for the missing child identification, the face recognition module will be crucial in identifying the face characteristics. And the sklearn module is used to achieve the face recognition mechanism with the KNN module. Coming to the phase three, so before performing the missing child identification, we need to train the classification model based on the customized dataset with the help of HOG and machine learning classifier. Each image will be retrieved from the dataset folder and get the facial features and perform the training operations. In phase four, we will work on a missing child identification system. So here we load the KNN classifier model by using the pickle module. The face detection process will be performed to extract the facial features from the children's images and then pass these features to the predictor module. Then the system will return the missing child information if the features are matched with the training features. Otherwise, it will upload the child image into the portal. Coming to the experiment, here the authority or user can upload the missing child details with the child image and they search the missing child by browsing the input child image. Then the system will perform the face detection methodology, HOG algorithm to extract face features. Thereafter, these features will be fed into a KNN classifier for missing child identification and then obtain the child information from the missing child database. We have the common portal where the missing child name and picture can be kept on a file. When a missing child is reported, the responsible officer uploads the child picture into the portal along with the details such as the location and the features of the person. The database photographs of the children are available for the public searching for any matching child. The most relevant situations will be suggested by the system. When the match is made, the officer can obtain the child's information. The next slide, please. Here, in the we have in the context of face recognition, pre-processing input raw photos includes obtaining the facial images and then standardizing images, which will be consistent with the HOG methodology that is used. When the missing child is reported, the officer uploads the picture along with the details and the complaint number into the portal. Then the system creates a pattern matrix of the facial characteristics from the photo whenever user or authority uploads a suspected child's photo. If the match is made in the database, then the system will display the most relatable image and then sends an alert message to the authority about the missing child. From here, my friend Nihant will continue. Thanks.
Thank you, sir. So, yeah. So coming to the result, so as I already mentioned this background work of the how the application works. So coming to the UI and all. So here we have like two modules, users and the officer. So user will be able to lodge a complaint by uploading the picture and the other details like the landmark, city where he was seen and all. At the same time, is also able to search through the existing missing children cases by uploading a picture. And the screenshot that we are seeing in this presentation is a matching found screenshot where the child was identified. And as you can see, all the details came up, and we can also see upload by Alice officer. So whoever is uploaded by whoever lodged that complaint, and even you can see the contact number as well. Contact them. And coming to the officers as well, so officers also have this same features. So officer is also able to lodge a complaint, and he is also able to search to the existing matches. And along with those, he can also see the complaints raised by the users, and what's the complaint status and all. So all those things will also be available to the officers. So this is the end result, like application end result. Yeah, so whatever I explained, it's over here. So even if there is no match found, you can see the no results found page or something like that. So though this all this is a UI thing, but we even haven't compromised on the core of the application, which is a facial recognition algorithm. So we chose the combination in such a way that it gives the best accuracy, and along with that, it's also robust and smart. Smart. So why it is smart? I'll explain it in the next slide. So as you can see here, we have compared with different combinations of classifiers and feature descriptors, and a couple of them doesn't even have this aging technique, and the others are low in accuracy. So compared to our combination of the algorithms. Yeah. So to conclude, like as I was already saying, so we did not compromise on the facial recognition algorithm itself. So the facial descriptor, which is a hog, is smart enough to identify other objects apart from the faces, apart from the human faces. So even if the picture was taken from far away, or picture was taken with other objects in it, so the hog based this specific is smart enough to basically eliminate all the other objects and capture the face. And along with that, we already know this Canon is good with visual images and all. So and it's also easy to train, and accurate in terms of giving the results. Yeah. So coming to the future work, so this application that we have developed, it's is not specific to use the smartphones or officer mobiles. So it can be even integrated with the cameras and street cameras and open air cameras and even satellite views. Yeah, so along with that, so that's what that's one way to basically improve the reach, and the other one is internationalization. So this application, we don't even have it stick to the just county or stick to the state. It can be internationalized, and missing children can be found internationally as well. So probably the missing child might be in a different country, and we can still find him by increasing the reach. Yeah. All right. So that's all about our presentation.
Thank you
Thank
for
you.
the opportunity, Professor. This is all we have. We conclude and have a great day. Thank you.